Hello guys, this is Dr. Possibility from Excel Academy. Kindly take note that Excel Academy is going to be offering physical, medical classes for second year students. And kindly note that we are also giving away an iPhone 7 128 GB to every student who is going to register with us for say 3 consecutive months. So in today's class, I'm just going to explain on gametogenesis. So previously, I explained on what meiosis is. So when you talk of meiosis, this is an important process that helps us to understand gametogenesis. And let's quickly look at this. So meiosis is just a type of cell division. So we are talking about cell division in sexual reproducing organism. So when you talk of sexual reproducing organism, we can also include human beings. Human beings, they sexually reproduce. And this process of meiosis, it helps in the production of what? Of gametes. Once again, when you talk of gametes, gametes are just sex cells. And there are actually two types of sex cells. We have what we are calling the egg, and we also have what we are calling the sperm. These are the only two sex cells that we have in the human body, of which every human being can either produce an egg or a sperm. So let's talk of the types of cells. We have two types of cells. The first type of cell that we have is what we are calling the somatic cells. So when we talk of somatic cells, they are also known as body cells. And these cells can include the nerve cells, they can include the muscle cells, they can include any other cell which is not a sex cell. And this type of cells, we need to take note that they have a diploid number of chromosomes. That means that they have 46 chromosomes. And when we talk of a diploid, we normally use the symbol 2n. Now, when you talk of a diploid cell, this cell contains two sets of chromosomes from each parent. When we talk of each parent, we are just simply talking about the female and also the male. So please kindly take note of this type of cells. The other type of cell that we have to consider is the haploid cells. So when you talk of the sex cells, when you talk of sex cells, these sex cells are of two types. We have the sperm and the egg, which is also known as the oocytes. And these cells, they have an important thing which we are calling the haploid number, which is denoted by 1n. And this sex cell can only contain one set of chromosomes from one parent. Let's quickly look at these same sex cells. So sex cells are also of two types. We have one, the sperm cell. We have two, the egg cell, which is also known as the oocyte. Remember, the sperm cell is found in the male, and the egg cell is found in the female. Please take note that your lecturer, your tutor, or your examiner might not use the word egg cell. Instead, the word which will normally be used is the oocyte. So wherever you see the word oocyte, we're simply talking about the egg cell. Now, kindly take note that these are the only two cells that undergo meiosis. Alright, so if you look at this picture of mine, you can find that we have two types of cells which have been illustrated. We have the sperm cells, we have these sperm cells which are going around there, and we also have the central cell which is the egg cell. This is the oocytes, and then these are sperm cells. So when we quickly look at that, we can simply look at an overview of these two cells, of which that is an oocyte. I'm pretty sure you are not confused looking at this picture. So this is an oocyte. So this oocyte, we also have another sex cell, which is the sperm cell. Take notes, that one is an oocyte. This other one is simply a sperm cell. Let me quickly give an overview of this process of meiosis. So when you look at the process of meiosis, you have the parent cell. So this is the parent cell. Okay? So this parent cell is going to do what? It's going to give out two cells. And these cells will be that cell and the other cell. So from this point to that point, like we said in the previous video, this point is meiosis 1. Okay? And then this cell will also undergo the second meiosis, and this cell will also undergo another second meiosis. So this guy will produce that cell, that one will also produce another cell, that one will produce that cell, that one will also produce that cells. So these are the 4 daughter cells which have been produced. This one, that one, that one, and that one. So from this point to that point, from that point to that point, that point, that point, that point, that point, this is what we are calling meiosis 2. This is what we talked about in the previous class. Now, if you look at this parent cell, it contains the chromosome. It contains the chromosome which has what? 2n. Okay, so the chromosome there, they have 2n chromosome, but this one has 1n, that one has 1n, that one has 1n, and that one has also 1n. The question is, what about these two? So please find out and kindly WhatsApp me on my line the answer. So let's quickly go on the next step, which is our main objective. And our main objective is for me to explain what gametogenesis is. So gametogenesis is just the process by which gametes or germ cells are produced. Gametogenesis is just the process by which gametes or sex cells, when you talk of gametes, we are simply talking about what? Sex cells, which is the sperm and the egg. So when you talk of gametogenesis, this is the process by which the sex cells are being what? Produced. In what? In sexual reproductive organisms. Now, this gametogenesis, it helps to produce what we are calling an haploid number of chromosome. An haploid number of chromosome from what? From diploid. So we have a diploid cell. And this diploid cell, it has to produce what? An haploid cell. So this process from this one to that one is what we are calling gametogenesis. And this gametogenesis, it occurs by the help of what? Meiosis. Okay? Now, I have this picture of mine of these two people. I'm sure you can see a muscular man here and you can also see a beautiful woman here. So I have these two people. These two people have two different cells. This one has an oocyte, this one has an oocyte, and this one has a sperm cell. Okay? Oocyte, and this one is a sperm. But the question is, do you think gametogenesis in these two individuals is the same? Do you think gametogenesis in these two individuals is the same? Please comment and submit your answer. So let's quickly look at this. Let's quickly look at gametogenesis in male. As you can see, I'm joined by my friend Henry, who is putting on a blue t-shirt that side. So Henry is undergoing gametogenesis. And this gametogenesis in Henry is just representing the male sex cells. So when you talk of gametogenesis is male, it also undergoes meiosis. And the major product is to produce the sperm. Okay? So I'll start from the first cell where this sperm start from. So a sperm comes from a what? A primary spermatocyte. So the process of gametogenesis in male, it starts from the what? Primary spermatocyte. But remember, this primary spermatocyte, there is also a primary oocyte. These two, they have where they come from, which I'm going to explain later on. So the first cell which you need to understand is what? The primary spermatocyte. And this primary spermatocyte just has what? A diploid number, which is 2n. So the primary spermatocyte will undergo meiosis, to produce what? A secondary spermatocyte. Remember, here there is a change from 2n to n. This means that meiosis 1 has taken place. So here, meiosis 1 has taken place. Meiosis 1 has taken place. So it is meiosis 1 which is producing a secondary spermatocyte from a what? A primary spermatocyte. So when this one of these secondary spermatocytes undergoes meiosis, it's going to produce what we are going to have a spermatide. This spermatide, it is what we can also call a sperm. So from this point to that point, from secondary spermatocyte to spermatide, there is a process which is meiosis 2. So here there is meiosis 2, there is meiosis 2, meiosis 2, meiosis 2. So if you look at this process is the same as what I was explaining on what? On meiosis in the previous video. This video I've just given an overview. But in the previous video, I have explained what meiosis 1 is, the stages of meiosis 1 and the stages of meiosis 2. So make sure that you go through and you are able to follow. So remember, from primary spermatocyte to secondary spermatocyte, there is a change in the number of chromosomes from diploid, okay, from diploid to what? To haploid. From diploid to haploid. But from haploid, from secondary spermatocyte so to spermatide, there is no change in the number of what? Chromosomes. There is no change. Take note of that. There is no what? No change. Because this is meiosis 2. There is no change in the number of what? Chromosomes. So quickly, Let's look at gametogenesis in females. I'm joined by my friend here who is Grace. So Grace here should represent other female organisms, other female human beings. So the job is the same. It will start from what? Primary what? Primary oocyte. So from primary oocyte, remember there was a primary spermatocyte. Now we have primary oocyte. So the primary oocyte is the first one which is starting the process of what? Meiosis, the process of gametogenesis in what? In female. I'm just giving the brief. I've not gone much in detail. So make sure that you subscribe and make sure that you finish up this video. So this primary oocyte, what will happen is that it will undergo the same cell division which happened in the primary spermatocyte. It will undergo meiosis what? Meiosis 1. So when it undergoes meiosis 1, there is a reduction from diploid, okay, to what? To haploid. So you need to know that the process of meiosis 1 is a reduction process where a diploid is now changed to haploid. Get that? A diploid is changed to what? Haploid. I'm sure you are able to see. So this secondary oocyte, it's going to undergo meiosis 2. So when it undergoes meiosis 2, something strange will happen. In the male, you discover that we add 4 sperms down there. But in female, it is different. We are going to have 3 polar bodies. That is an exam question. How many polar bodies are produced at the end of the process of gametogenesis in female? There are 3 polar bodies. So, and what? 1 ovum. Only 1 egg. So this ovum is the oocyte. This ovum here is the what? The oocyte. The female gamete. The female sex cell. And these primary polar bodies, they just regenerate. We'll talk about that in detail. Alright, I'm sure we are enjoying, but I'm also being accompanied by my friend James there. So James is wondering and is asking me a question. So what's up, James? So James is asking me, Doc, possibility, where do this primary oocyte and spermatocyte come from? Comment. Give me your view. What do you think? Do these primary oocyte and spermatocyte come from? Give me your view. What do you think these cells come from? Let's quickly look at the answer. So there's my response. Don't laugh at me, that's me there. So when you talk of primary oocyte and primary spermatocyte, they come from the primordial germ cells. So the primordial germ cells, it is where these guys come from. And these primordial germ cells, they have a diploid number of what? Chromosome. They have 2 sets of chromosome, which is 46 chromosome. Okay, 46 chromosome, making up 23 pair. Making up what? 23 pair, because chromosome, they exist in pairs. So they're going to make up 23 pairs, which is adding up to 46 chromosome. And that 46 is indicating a diploid number of chromosome. Now, these primordial germ cells, where were they made? Where were they formed? Where were they created? So these primordial germ cells, they are formed from the walls of the yolk sac. You learn about this yolk sac later on. So they are formed from the from the walls of the yolk sac, and they move to the gonads. They move to the gonads. Not only the ovary there, I'll put the word the gonads. So when I talk of the gonads, I'm talking about the male and the female sex parts. So they move from the what? They move from the yolk sac to the what? To the gonads. In which week? And this happens in week what? Week 6. Take note of that. The primordial germ cells are the derivatives of the primary oocyte and the primary spermatocytes. Okay. Now, we have learned that. I'm sure someone is here wondering and trying to ask me a question. There, we have another question. So in this question, there is the possibility. I think this sounds interesting. Can you please explain more on male gametogenesis? I'm sure you want me to explain more on male gametogenesis. Let me quickly give you what male gametogenesis is all about. So male gametogenesis is classified into 3 phases. So there are 3 phases in which this male gametogenesis is classified into. There is one which we can talk of spermatogenesis. We also have the second one, which is meiosis. We also have the third one, which is spermiogenesis. Remember, I've said 1, it is spermatogenesis, spermatocytogenesis, then we have meiosis, then we have spermiogenesis. So let's quickly look at the individual of these guys. So I'll start with spermatocytogenesis. Okay, so when you talk of spermatogenesis, now we are trying to look at the beginning of this process. So spermatocytogenesis, when you talk of this is now where the primordial germ cells, remember what I was explaining. So the primordial germ cells, which is having a diploid number of cells, will move from the walls of the yolk sac and arrives in the what? In the testes. So the gonad part of the male, it is the testes. So these primordial germ cells, they will need to move from the walls. They will need to move from the walls of the yolk sac and reach the what? The testes, which can be somewhere there. They have to reach the what? The testes. It has to move. Now, in which week does this happen? This normally happens in week 6. But one thing you need to know is that after they move, these guys, they remain dormant, meaning nothing, okay? They don't do any reaction until they reach what? Puberty. So at puberty, that is when the primordial germ cells begin to undergo the process of differentiation. That's when now they will start dividing. So the primordial germ cells, it will just move from the walls of the yolk sac to the what? To the testes in week 6. Once it moves from that point, it will become dormant. Nothing will happen. Okay? Until a person, that baby is born. When that baby is born, then they will undergo differentiation, and that is during puberty. So at puberty, primordial germ cells differentiate into type A. So there is type A and type B. So there is this type A, which is the type A spermatogonia. So type A spermatogonia has a diploid number of chromosome. It has a diploid number of chromosome. A diploid number of what? Chromosome. Not a haploid. Okay, now this type A or spermatogonia, it is coming from the primordial germ cells, which had to differentiate during what? Puberty. So this type A spermatogonia, it's going to undergo the process of mitosis. It's not going to undergo the process of meiosis. No, it's going to undergo the process of what? Mitosis. This is also an exam part. So the type A spermatogonia, it's the only one which undergoes the process of what? Mitosis, to provide a continuous supply of the stem cells throughout the reproductive life of the male. So these guys, they are going to be they just undergo mitosis every time. They make sure that once a primordial germ cells changes into the type A spermatogonia, this type A spermatogonia is going to be undergoing mitosis, and it's going to be providing the what? The stem cells. And these cells, they are the ones now that which we are going to help the process of the formation of the sperm. So some type A spermatogonia differentiate into what I said, type B. Remember, type B is also having a diploid number. It is also having a diploid number. The question arises, how come this guy is having a diploid number of what? Chromosome? The reason is simple. It's because type A it's undergone the process of mitosis and not meiosis. This process of mitosis is going to produce only a diploid number of chromosome and not an haploid. So a type A spermatogonia, it's just going to undergo the process of mitosis, and this process of mitosis is going to produce a lot of different spermatogonia. But amongst these different spermatogonia, some type A, they differentiate into what? Type B spermatogonia. So these type B spermatogonia are our area of what? Interest. So these type B spermatogonia, they are now going to undergo the process of meiosis. Remember, in the spermatocytogenesis phase, there is only mitosis taking place. What are we saying? The primordial germ cells, they changed into type A at puberty, and this type A, it's changed into type B spermatogonia, and this happened by the help of mitosis, not meiosis. So this type B now is going to change. It's going to undergo the process of meiosis, and that will give us our second phase. So let's quickly look at our second phase. So our second phase, it is meiosis. What's going to happen to meiosis? So the type B spermatogonia, it's now going to undergo the process of what? Meiosis 1. And this type B which has undergone meiosis 1, it's the one now which is going to give us the what? The primary oocytes. So the primary oocytes, they contain what we are calling the 4N. They are the only stem cells of sperms which have a 4N. Go through papers, go through different sources on embryology, you shall be asked about the primary spermatocyte. So the primary spermatocyte, they have 146 chromosome, but when you talk of this, it is not going to be 2N, it is not haploid, it is not diploid, instead it is 4N. And these primary spermatocytes are coming from the what? They are coming from the type B spermatogonia, which came from the what? The primordial germ cell, which came from the type A, and the type A came from the what? The primordial germ cells. And these primordial germ cells, they came from the walls of the yolk sac. Okay, so now this type B has differentiated into primary spermatocytes. A lot of people will not tell you about this 4N. It's very important for exams. So from here, this primary oocyte will also undergo the process of meiosis. So this primary oocyte, it is in between the beginning and the end of meiosis 1. So this primary spermatocyte is now going to complete the process of what? Meiosis 1, to form the secondary spermatocyte, which is now having a what? A diploid. So which is having, not a diploid, which is having a two sets here, which is having a diploid. But these two sets of chromosomes have only 23 chromosomes. 23, not 40. Look, here, this was 46. 46 has gone to 23. And this 4N has gone to what? 2N. For the primary oocyte, when it completes meiosis 1, it's going to form secondary spermatocyte. Now, this primary is going to secondary. Secondary automatically needs to undergo the process of what? Meiosis 2. So this process of meiosis 2 is now going to produce what? 4 spermatides. These 4 spermatides are what we are calling the what? The sperms. Okay? So 4 spermatides will be formed, and these 4 spermatides, they are going to have an haploid number of what? Of chromosome. An haploid number of chromosomes. Remember this N, when you check out my previous video, this N is just referred to a ploid number. Okay? So they're going to, these spermatides, they come from the secondary what? Secondary spermatocyte. And these secondary spermatocytes are just completing the process of meiosis 2 to form what we are calling spermatide. And how many are these spermatides? There are just 4 of them. Now, let me quickly give a summary of this work. So the summary here is that the first thing we had was the what? The type B spermatogonia. So the type B spermatogonia is going to give what we are going to have what? The primary spermatocyte. So from this point to that point, there was meiosis 1. So here there is meiosis 1, and then from there, primary spermatocytes, they are going to give us secondary spermatocytes. And here there was also meiosis 1. And then from there, we are also now going to know that the last part which happened during this process was the spermatides. Okay, so with this being said, we are now going to go on the last phase. So the last phase after the whole process has taken place, the last phase, which is the spermiogenesis. So let's quickly look at spermiogenesis. What happens? So remember, spermiogenesis, in the previous explanation I said the last thing which we had was the spermatide. So now we are going to get the spermatide. We are going to get that spermatide and know what we are going to see. So that spermatide will undergo post-meiotic series, and this post-meiotic series, their aim is just to make some morphological changes. Okay, so let me give you that. So spermatides undergo a post-meiotic series to what? To change the what? The shape. Okay, morphology is talking about the what? The shape. So at this stage, the stage of spermiogenesis, there is just the change of the shape of the sperm. Just to change. Where is this? Where is this happening? I think we need to ask ourselves, where is this actually happening? So this is happening in the epididymis. This is happening in the epididymis. That's where this process is taking place from. Because the person has already reached puberty. Automatically, we need to know that this is a male. That's why a male will always produce sperm. So, in the epididymis, this guy will undergo morphological changes to form what we are calling a sperm. So it is from the four spermatide, like I said, this four spermatide will quickly form what we are calling what? A sperm. Four sperms. Nothing has changed. There we had 23,1 N and haploid. Even here it is. Why? Because a spermatide does not undergo any cell division. You get that? You're going to be examined on that. Which one doesn't undergo cell division? It is the spermatide. Everything we have talked about, it undergoes cell division except the spermatide. Now, these changes include, what do they include? The formation of the acrosome. In the next classes, I'm going to talk about the acrosome reaction. Okay? So, what are these changes? So, the first change that we need to observe is the formation of the acrosome. Then the next one, it is the condensation of the what? Of the nucleus. The last one is the formation of the head, neck, and tail. It is the morphological changes. So there has to be the formation of the acrosome, the formation of the condensation of the nucleus, and the formation of the head, neck, and tail. We'll look at that later. So now we have talked much about this. Can we really know the time which takes for this process to happen? So this process, it takes about 64 days. So meaning from the genesis, from the we are not talking, remember, we are not going to talk about the sixth week. No, we are just going to pick it up from puberty. So every day there is a continuous continuous formation of sperm. Every sperm that you see today, it is a sperm that was formed like 64 days ago. So the process started 64 days ago. From the what? From the spermatogonia to the spermatozoa. The word spermatozoa can also be said to be what? The sperm. From the spermatogonia to the spermatozoa. All that period of time, it takes 64 days. So every sperm you see today was created about 64 days its creation started 64 days, okay, which is, can we say 2 months? 2 months, 4 days, or 2 months, 3 days, depending on the month. Now, yes, the sperm has been formed, but the newly formed sperm, which is just ejaculated, cannot cause fertilization. Okay, please take note of that. The newly formed sperm cell is incapable of fertilization. It cannot fertilize an egg until it undergoes what we call capacitation. Why? Because there is this acrosome around it, there is a membrane around it, there is something that is covering it up. So the newly ejaculated sperm cell cannot cause what? Cannot cause fertilization. So for this to happen, for fertilization to happen, there is an issue of capacitation, there is an issue of acrosomal reaction, and all these, they happen in the female reproductive tract. Okay, so can we say the males, they totally depend on the female? Because even the sperm will not do its job until it is inside there. We'll talk about this more when we discuss. Yeah, so we'll talk about that more. So make sure that you subscribe to our YouTube channel, and make sure that you subscribe to our YouTube channel. Oh, I have my friend there. This should be Ronald. Ronald has some good swag, you know. So what is Ronald trying to ask me, or what is he trying to say? Okay, yes, Ronald, how are you? I'm sure Ronald is fine. Okay, let's get there. What is Ronald saying? Well, thank you, Doc Possibility. I now know how my sperms were formed. I always used to wonder how this thick, creamy liquid came from. Hey man, you don't listen. I hope now you know where your sperms came from, and I hope you now believe in the science behind it. Anyway, I can hear some noise in class. I'm pretty sure there's someone who's trying to ask something. Oh, there is an advert. Sorry guys, please make sure that you register with Excel Academy by just contacting me on the lines which you are able to see there. So please make sure that you support us also by sharing the video, subscribing to our YouTube channel, and also make sure that you register with Excel Academy. When you open, we're going to be having some physical classes. Please make sure, take advantage of us. We are here to serve you. Thank you. Let's continue. Mary, I'm sure Mary, she's enjoying a new year. Yes, Mary, looking cute. What do you have for me? Oh, she's standing. All right, okay, cool. I'm really enjoying this lecture. All right, thank you, Mary. Can you kindly explain to us about female gametogenesis? Really? Should I? Okay, let me do that. So I have my egg there. Oh, that's Mary's egg. So there we have an egg. So in this egg, we need to look at the female gametogenesis. So the same thing will happen whereby the primordial germ cell from the walls of the yolk sac arrives in the ovary. This time around, it is the ovary at week 6, and they now differentiate in what we are calling the oogonia. Get that? So there we had spermatogonia, now we have the oogonia. So at week 6, the primordial germ cells, they are going to travel from what the walls of the yolk sac to the ovary, which they are going to undergo differentiation, and when they differentiate, they are going to produce what? Oogonia. Okay, so this oogonia is now also going to undergo the process of mitotic division. So oogonia enters meiosis 1 and undergoes DNA replication. So there is DNA replication to form what? Primary oocyte. Now, when does this happen? So this primary oocyte, they happen in month 5 of fetal life. So remember, in male, it happened after puberty, but in female, it's happening at month 5. So that's one of the differences. In male, it is puberty. In female, it is what? It is at month 5. This means that there is no oogonia present. There is no oogonia present at what? At birth. But in the male, the spermatogonia was there during birth until puberty. But in female, this guy is not there. The oogonia is not there. It's not there at birth, including at puberty. So what exactly happens? So what happens is that the primary oocyte, when the oogonia changes to primary oocyte on 5th month of fetal life, this primary oocyte remains dormant, at which point at the prophase 1, okay, at prophase 1, the primary oocyte become dormant from what? From month 5 of what? Of fetal life until puberty. So the primary oocyte, it becomes dormant. Nothing, it undergoes nothing. It's more like sleeping. It's more like sleeping. It's not undergoing anything. And at which point is this? It is at what? Prophase 1 of meiosis 1. Now, after puberty, 5 to 15 primary oocyte are produced. That's why a woman undergoes the menstruation after puberty, because of the release of these primary oocytes, which are now going to undergo the process of meiosis 1. Remember, this process of meiosis 1, it rested at prophase 1, so it's going to continue. It's going to continue. So this 5 to 15 primary oocytes are produced every month, and these guys, they begin maturation, okay, with each ovarian cycle. And these guys, only 1 out of 5, let's say there are 5, only 1 will be produced, and this is the one which is what? Which you see. Even if there are 15, still 1 will be produced. Now, if you wonder, we have twins, not identical twins. We have some twins who look like siblings. So those twins, there is a chance that these two, amongst the 5, maybe 2 of them, they reach what? The menstrual cycle, and then the sperms had to fertilize them. So that's why we have such twins. So, but in a normal case, only 1 of them matures and reaches the full what? Menstrual cycle, and 1 egg every month, an egg is what? Is produced. Now, during the ovarian cycle, you need to note that there is a sac of the hormone which is called what? The luteinizing hormone. So the menstrual cycle will be explained by my colleague, and please make sure that you attend his lecture. So because of the sac of this hormone called the luteinizing hormone, the primary oocyte which were dormant at prophase 1, they are going to what? They are going to complete the what? They are going to complete meiosis 1 to form 2 daughter cells, and these 2 daughter cells, when these 2 daughter cells are formed, you need to know that one of them is the secondary oocyte, and the other one, it is the first polar body. So the first polar body, it is produced during the menstrual cycle after puberty from the primary oocyte. So the first polar body will be produced, and then the other part, because the primary oocyte has divided into two daughter cells. So this is the primary oocyte. So when you look at this primary oocyte, it has divided into two. So we have one and we have also another one. This is meiosis one. So this one is a polar body, and this one is the secondary oocyte. This one is a secondary oocyte. Okay, so this secondary oocyte, it is now going to undergo some cell division. It's going to begin the second cell division, but it doesn't complete the second meiosis. Why? Because it gets arrested at metaphase 2. So at metaphase 2, the secondary oocyte is arrested. So how many times does the oocyte get arrested? It gets arrested what? Twice. The first one, it is the primary oocyte, which is arrested at prophase 1. The next one, it is the secondary oocyte, which is arrested at what? Metaphase 2, which is normally 3 hours before ovulation. Before a woman starts ovulating, 3 hours before that, this secondary oocyte, which was produced with the polar body which had to degenerate. So the primary oocyte, okay, the primary oocyte has what? Has produced two daughter cells. The primary oocyte has produced two daughter cells, and these two daughter cells, one of them is the polar body, the other one is the secondary oocyte. So the polar body will degenerate, and then the secondary oocyte will continue the process, but it's going to be arrested at the metaphase what? 2 of meiosis, and it remains dormant until fertilization occurs. That's why a woman has to wait for the sperm to fertilize the egg for them to be pregnant. That's why a pregnant woman doesn't undergo menstruation. Why? Because the egg has been what? Has been fertilized, and some changes have been made. So let me quickly go on the next one. Sorry for the rinse. So here you have, this is the egg, so when you talk of this part, this can be called the secondary oocyte. So this is the secondary oocyte. Okay, this is the secondary oocyte, and this secondary oocyte, you simply have that polar body there. So this is a polar body. So there is the polar body. Okay, I'm sure you can see something like zona pellucida, the cytoplasm. This zona pellucida, we are going to discuss it later on and know its function. So this, they came from what? The primary oocyte. Okay, so at fertilization, in case a girl had some sexual intercourse, the secondary oocyte completes meiosis 1 to form a mature oocyte, and this mature oocyte has what? An haploid number of chromosome with a second polar body. So sorry guys for the rinse, and please make sure that to subscribe to our YouTube channel, and also contact me on 09658874744. So for those who are international, you can just simply put the code +26 and you're going to reach me. Thank you very much guys. This was Dr. Possibility from Excel Academy. Have a blessed day.